Hi, I'm Ali, a maker working on a variety of projects ranging from autonomous robots, underwater ROVs, embedded systems like greenhouse control systems, to code for SpaceX-like self-landing rockets. I'll briefly summarize some of my projects in this video. Since 2020, I've been learning ROS and working on autonomous navigation robots. I didn't have a clear goal in mind while working on this project. I worked on it to learn and tinker around. I first started work with the standard two-wheel drive robot kit that I bolted a Raspberry Pi and a LiDAR to. I then started designing my own base with Mecanum wheels, which used DC brush motors with encoders for the wheels, a Raspberry Pi for the SLAM system, and an Arduino for motor control. The biggest problems with this design were that there was no extra space for any additional equipment, such as an IMU. The exposed wheels also broke quite frequently, so I got back to the drawing board. I started designing a new base with the wheels completely enclosed. It had enough space to house a power control system for a charging dock. However, the DC motors were not good enough for precise motion and couldn't make the robot dock to the charging port. The system also used Wi-Fi for internal communication, and which turned out to be unreliable and introduced a lot of lag. Back at the drawing board, I redesigned the drive base with stepper motors and added a crude suspension mechanism so that it could go over small obstacles. I also moved to Ethernet instead of Wi-Fi for communication, which improved the latency quite a bit. It is capable of mapping large areas, as far as the Wi-Fi connection can go at least. Here is the map of my school it graphed. It is also capable of autonomous navigation around spaces while avoiding obstacles, using Nav2. Here, the robot is navigating around my FRC team's lab and my school. With the addition of a camera, this system is capable of docking to the charging port now. I then realized the practical application of this robot. With the addition of a robot arm, this can be used as a mobile 3D printer. I applied for a patent of my idea and designed a robot arm with a robot large enough to house it. I then wrote an inverse kinematic solver for the arm and a communication protocol for the controller. The inverse kinematic system is capable of solving for a single point, a straight line, or a path. After countless prototypes, the arm is functional now. I also designed a replaceable cartridge-based battery system in order to allow the robot to continue operating while its batteries are charging. They get automatically replaced at the battery charging station. After some testing, I realized that the LiDAR-based LAM system was not good enough for precise localization suitable for this application, so I started researching alternatives. I'm planning to use multiple cameras and AR UCO tags for precise localization. In order to run the stepper motors of the base and arm fast enough, I wrote a custom stepper motor driver that makes use of the waveform generator of the Raspberry Pi. It can output about 200,000 step pulses per second with acceleration and position control. It took me quite a lot of debugging to get this working. I was lucky I had an oscilloscope I could use. I even had to isolate the core from the Linux scheduler. I also spent about 2 months designing custom PCBs for the new robot. I designed a 4-channel step motor driver and a modular power control board, each with custom Ethernet circuitry. Unfortunately, even though I got them fabricated, I couldn't import them to Turkey because they got rejected from customs. I'm looking forward to studying abroad where there are less restrictions like this. As for some of my other projects, I am the software team lead of my FRC team, Cosmos Robot Works. We not only compete in the FRC, but we also host our own robotics competition every year. In 2023, we had over 50 participants, and in this year, we are hoping to push that to over 100. We are planning an ambitious new game, which will include my autonomous navigation robot as part of the game elements. I am also a member of my school's underwater ROV team, where we got first and third place awards in 2020 and 2021. We are developing a robot capable of rotating its thrusters in various directions to be faster and have an advantage over other teams. I also worked on my school's automated greenhouse system. We designed a modular system that can be configured for any kind of greenhouse configuration. It has support for capacitive and I2C soil hygrometers, air carbon dioxide and humidity sensors, watering valves and ventilation control. It can also be controlled remotely and logs its data into a database for us to analyze. That summarizes most of my major project. Most of my code is available on my GitHub profile. Thank you for watching,